All right. Welcome back, everyone. Hope we had a decent lecture in Math 161 earlier. So if you missed it, remember that you can go back and catch the replay on YouTube. It should be available within a couple hours after class is over. But yeah, today what I figured we would get into is talking about polynomials. So we're going to talk about what it means to be a term, what it means to be a degree of a term or the degree of a polynomial, how to add, subtract, and multiply them. Then we're going to get into some introduction of factoring with them, and that'll probably be where we leave for the day. If you missed last class's lecture, remember you can catch the replays on YouTube while we are online. Remember that we're going to be doing the Zoom thing through January. February 1st is when we're supposed to go back to campus tentatively, but that of course could change depending on how the Omicron stuff goes. So keep your eyes and ears to the ground. Keep your eyes open, ears to the ground. That's the more appropriate thing. Last time we talked about what it meant to be a rational or an irrational number, interval notation, your exponent rules, and some stuff with radicals as well. So again, today what we're going to be discussing are polynomials, which are just a sum or difference a coefficient that's a very generic definition. It's just a bunch of things being added or subtracted, and they can be both. You can have a plus and then a minus and then a minus and then a minus and then another plus. It can be 2, be 7, it can be 11 terms. Coefficients are your numbers in front. Factors. Y, maybe something like x squared y. I have to write that one, etc. 3, exponent, or sum of exponents. There's more than one variable in the term. So if you had an x to the third, the degree would be 3. If you had an x to the fifth, the degree would be 5. If you had x squared y, the y has an exponent of a 1, assumedly. So the degree would actually be a 3 because you take the 2 and the 1 and you add them. You don't actually add them and change it. I'm just saying to find the degree, you would add the 2 and the 1. Again, you couldn't actually combine that in any other way because they don't have like bases. All we can do is talk about the degree. The number of terms is one way we can for instance, terms, binomial, more than that, we just say terms separated. So 5x would be a monomial because there are no pluses or minuses and other variables and numbers. X plus 3 would be a binomial because you have the x and the 3. X squared plus 7x plus 11 would be a trinomial because you have the x squared, the 7x, and the 11. Or x squared minus 7x plus 11 would be a trinomial as well. Example 1, we're going to identify the degree of each term, the type of polynomial, polynomial. And I haven't said what that last thing is. Like we talked about the degree of a term. But what about the degree of a polynomial? So leave some space for one more definition before the example. And I just want to see if we might be able to figure it out inside of an example. All right, so for A, we're going to go with 3x squared is 5x minus 8. I'm actually going to do the type first. And by type, I mean monomial, binomial, trinomial, 5-term polynomial, 12-term polynomial, etc. So we have 3x squared, that's one term. We have 5x, that's another term, and minus 8, that's another term. So there are 3 terms, so we'd call that a trinomial. For the first term, first degree is going to be, well, that's this term right here. And that would be a 2 because it has an x squared. The second degree, we're talking about the 5x. There is no exponent right here, so we assume it's a 1. We don't ever write it, we just assume it. That's a 1. And a third degree, that's for the minus 8. And it does count as a minus 8, a negative 8, because of the minus sign. I want to say, what is the degree of that one? Some people might say 8, but no, 8 here is actually the coefficient, it's the number. In fact, because there is no variable, you can even give this a special name. This minus 8 is a constant because there's no variable. So it's still a coefficient, but it's also a constant. Now, there are no x's here. There are 0 x's here, which means the degree is 0. There are 0 variables there. So that one might seem a little tricky. But if you go back to your exponent rules, you might remember that anything to the 0 power is equal to 1. So I could actually just kind of put an x to the 0 right here because that's like multiplying by 1, and then you can see the 0. How about the polynomials degree? The one that I didn't have a definition up here. Some people might think that you're going to add the 3 degrees, the 2, the 1, and the 0, and you get a 3. And that's not it. What you do is you actually take the largest degree out of all the terms. Degree polynomial, the largest degree. So we have options of 2, 1, and 0. So the polynomials degree is 2. We can also call the term that has the polynomials degree, the largest exponent, we can call that the leading term. So 3x squared is the leading term. And that's something that you'll hear me refer to frequently. The leading term is the term that has the highest exponent or sum of exponents if there's multiple variables. B. Go with negative 7, x to the 5th, y to the 7th, plus 13, x to the 10th. So the type on this one, I see 2 terms. Now you might say there's like 1, 2, 3, 4, 5 terms, but there's no pluses and minuses separating the 13 and the x squared or the 7 and the x to the 5th and the y to the 7th. This is the only plus or the only minus separating terms, so it's a binomial. You might say, well, Mr. Beckner, I see this minus and this plus. But there's nothing separating this minus 7 from something else, which is why it doesn't make it a trinomial. The first term's degree, it's not 5, it's not 7, it's actually 12, because you have to add those because they're paired together. The second term's degree is the 10. There is no third term, there's no fourth term, so we stop there. We go straight to the polynomials degree. You have to be careful here, it's not the largest exponent, it's not the 10, it's the degree of the leading term. It's the degree of the sum of the variables from a term, the largest one, that is. So 5 plus 7 was 12. Polynomials degree is 12, the 12th degree polynomial. Something we don't really deal with a lot in here, but you can still see it. Okay. So let's talk about how to add or subtract. Like terms. Subtract, whichever it says to do. Coefficients, terms, not change them. In other words, 5x plus 7x would be 12x. 5x squared plus 7x squared would be 12x squared. I'm just adding or subtracting the numbers in front and keeping the x's or x squareds whatever they were the same. But if you add a 5x plus a 7x squared, those wouldn't be matching variable factors because one of them's x and the other's x squared. Those aren't the same thing. The instruction to simplify, which implies that you are to combine like terms or do whatever else you could if there were other things to do, which there will be. Okay, let's go with 3x squared, 5x minus 7, plus 9x squared minus 6x minus 12. Now, sometimes you have like terms, sometimes you don't. Sometimes you have several like terms, sometimes you don't. Sometimes everything has a like term, sometimes only some of them have like terms. Depends on the problem, of course. So 3x squared, is there any other term that has an x squared? Well, sure, this 9x squared right here. This 9x squared is like 3x squared because they both have exactly x squareds there. So we can combine them. The 3x squared plus the 9x squared. All we do is add the 3 and the 9. It's simple. Oh. Then x squared and x squared makes an x to the fourth, right? No. There are times when you change exponents, when you multiply variables, but when you add and subtract them, you keep them the same. For the 5x, that's like the minus 6x. So that's a positive 5, that's a minus 6. Remember your rules of addition and subtraction. Different signs, subtract the numbers, keep the sign of the larger. 5 minus 6 is negative 1. Now, some people might write this as a minus 1x, but you really aren't supposed to write the 1. It's not simplified if you do that. And my math lab often will mark it wrong. Now, on a test, I'd go back and give you credit, at least most of the credit, but when you rather get all your credit right up front. So again, with just writing minus x, that implies that there's a 1. Don't write the 1 in your final answers. And then last but not least, we have a minus 7 here, and it's like a minus 12. Same sign, add the numbers, keep the sign. 7 plus 12 is 19. Keep the sign, so a minus 19. I'm just going to write this all in one color for the answer. There we are. B, and I'm gonna give you all a couple minutes to try this one on your own. Let's go with 11x to the third minus 4x plus 8 and plus 12x to the third plus 4x squared minus 5x plus 2. This one's a step up, but not very difficult, and that is a 4x squared. Let me just clean that up. Spoilers, not everything's going to have a like term, but that's okay. Just means less work, more dragging things to the answer. Take about 2 minutes and try that on your own. All right. Equals. The 11x cubed has a like term, that 12x cubed. So we can combine those, 11x cubed plus 12x cubed, 11 plus 12 would be 23. So 23x to the third. Now, I want to write these in what we call descending order. If you didn't do it that way, it's okay. But I got the x cubes first. Let me get the x squareds next. This is not an x squared. This is not an x squared. I don't have any x squareds until all the way down here. And there aren't any terms that are like it, which means I'm not going to combine it with anything. I'm just going to bring the 4x squared down. So I'm done with this term, this term, and this term. And if you want to cross them out as you use them, you can certainly do that. That's okay. Then we have the minus 4x and the minus 5x. Those are the what we call the linear terms. They have exponents of ones, and they're like minus 4 and minus 5 makes them minus 9x. They're done. And then we have the 8 and the 2, which make a 10. So again, if you wrote this as 23x to the third minus 9x plus 4x squared plus 10, that's still right. It's just not in the best order. This is what we call descending order. What's it descending based on? It's descending based on the exponent. We have the 3, then the 2, then the 1, and then the none, the x to the 0, the constant. That is a best habit, especially as we move into factoring, because most factoring hinges on having everything written in descending order, or things don't work out very well. I'm going to do one more of these on my own. And let's go with 4x squared y plus 5 xy squared plus 2 x squared y minus 7 xy squared. Be careful with those exponents, because x squared y, xy squared, x squared y, xy squared. They didn't have to be that specific pattern to anything. It's just what I chose to do. Some people will get confused and think all of these are like terms because they all have x's and y's, and that's far from the truth. In order for them to be like terms, they have to have the same degree of x's and the same degree of y's. This x squared y, when I say it out loud, is not the same thing as this xy squared, so they aren't like terms. You can't combine the 4 and the 5. But this x squared y is the same as this x squared y, so I can combine the 4 and the 2. 4 plus 2 is 6, so that gives me 6x squared y. Then we have a 5xy squared, a 7xy squared, a minus 7, excuse me, xy squared. I said the exact same thing, xy squared, which makes them like. 5 minus 7 is negative 2, so that's a minus 2xy squared. Just going to write this in the same color, 6x squared y minus 2xy squared. That's our final answer. We can't combine them because they're not like terms. All right. So that's adding and subtracting polynomial terms. What about multiplying them? Distribute these. Foiling is just a special case of. Foil means first, outer, inner, last. That describes the 4 different products you do in distributing the first parentheses, the second parentheses. This is for binomials only. Can't do that on anything else. Only for binomials times binomials, which means 2 terms times 2 terms. If you have 1 term times 3 terms, nope. You have 1 term times 2, nope. If you have 3 terms times 2, or 2 terms times 3, or 3 terms times 3, nope. Don't call it foiling. There is no first, outer, inner, last. It's just a special name for a special case. It's a mnemonic device to help you remember the pattern. The cool thing is it's what we end up multiplying the most in this course. But it doesn't mean it's the only thing. To distribute means you just take something and multiply it by all things in the parentheses. Simplify, which in this case would mean to multiply out the polynomials. So if I had 4x times, let's go with 3x squared plus 7x minus 2. A lot of people like to draw this up. When they say to distribute, they'll take the 4x times the 3x squared, the 4x times the 7x, and the 4x times the minus 2. I don't want to leave that there because it's covering up my writing. But if you like to do that little web, feel free to spin your webs. So the 4x times the 3x squared, I will show in black. You're just taking the 4 times the 3. And I'll show out the explicit step, 4x times 3x squared, plus then the 4x times the 7x, and minus the 4x times the 2. See, I give whatever these signs were or what you have here. So again, that's the step that most people don't ever write, showing the direct multiplications. 4x times 3x squared, you take the 4 times the 3, the constants, the coefficients, and make that a 12. X times x squared. Now this isn't adding or subtracting, this is multiplying. This is where your exponents change. 1, 2, we went over that rule last time, you add them to get a 3. Then plus 4 times 7 is 28. X times x, that's x to the first times x to the first, which is x squared. Think about it this way, if you had 3 times 3, that's 3 squared. So x times x is x squared. The 3 squared you could, of course, write as a 9, but that's not the case for variables. Minus 4 times 2 is 8. There's nothing to do with the x, so you just bring it down. And that would be our answer. That's what distributions look like. Pretty simple, it's pretty clean. As long as you remember your exponent rules, not too bad. I want to make that box better. For B, let's go ahead and step this up a notch. X plus 3 times 2x minus 5. We're already at the foiling because this is a binomial. X plus 3 has 2 terms, and a binomial 2x minus 5 has 2 terms. So we're going to go first, outer, inner, last. And I'm even going to write this as first, outer, inner, last. First means the first term from each parentheses. So first would be the x and the 2x. That's the first. So x times 2x, x times 2x, and I'll do this only one time. That's the first, the x times the 2x. I need to give myself a little more room with the OINL because of that. So again, I'm not going to show this explicit step anymore after this. First, the x times the 2x. The outer, that would be the 2 that are furthest away from each other. 1 from each parentheses, that's the x, and not just a 5, the minus 5, include the signs. So those are the outers, the x and the minus 5. So a minus x times 5 or a minus 5 times x. If you want to write plus x times negative 5 and be super explicit, you can. Plus. The inner are the 2 closest to each other, 1 from each parentheses. That's the 3 and the 2x. So plus 3 times 2x. And then the last is the last one from each parentheses, which is the 3 and the minus 5. Plus 3 times negative 5. Again, how you write out your signs and everything is up to you. Most people aren't going to show this step. I'll never show it again. If you need to, go for it. X times 2x, we'll leave the 2 alone. X times x is x squared. Adding the exponents, a 1 and a 1. X times negative 5 makes that a minus 5x. If you really want to write plus negative 5x, you can, but at this level, no one really does. 3 times 2 is 6, so that's a plus 6x. 3 times negative 5 is a minus 15 or a plus a negative 15. Now you might think you're done here, but what happens, I would say 90–95% of the time when you FOIL is you will need to combine like terms. Very often the outer and the inner will be like. Not the only possibility, but it's the most common. Negative 5x plus 6x, negative 5 plus 6 is a positive 1. That gives us 2x squared plus, I'm not going to write the 1 permanently, but that is a 1. That was from the negative 5 plus the 6. And then a minus 15. Our answer. I'm going to give 2 of these to y'all to try in about 4 minutes, something like that, roughly. Let's go with 2x minus 6 and 3x plus 8. That'll be C. And then we'll go with 5x plus 3 times 5x minus 3. That one's kind of a special case that we'll get to talk about a little bit later. We're going to take 4-ish minutes to try those out. And spoilers, there will be like terms to combine for both of those as you go. All right, I'm gonna get some help on this one from y'all. So for the, and again, I'm gonna skip the x times 2x part. Let's just go ahead straight to the answer. So for the first, that's the 2x times the 3x. What did we get with 2x times 3x? How about it?
6x squared.
6x squared, that's awesome. Then for the outer, that was gonna be the 2x times the 8. What do we get for 2x times 8?
16x.
Plus 16x, great. Then for the inner, we got our minus 6 times our 3x. How about that one?
Minus 18.
Minus 18x. And then for the last, that's the minus 6 times the positive 8. What did we get for that?
Minus 50.
You're in the ballpark, but it's not 50. Try though. 6 times 8.
Minus 48.
Minus 48. There we go. No sweat. And then when we combine our like terms, the outer and the inner, we'll leave the 6x squared alone. 16x minus 18x should be a minus 2x because the larger is negative. And then we leave the minus 48 alone as well. So that would be our answer. There we are. Now for D, same thing. Let me get some help. And then afterwards, I'll talk about a special thing that happens here. The first, the 5x times the 5x. What did we get with 5x times 5x?
25x squared.
25x squared, that's great. For the outer, that's the 5x times the negative 3, the two that are furthest apart. What did we get?
Minus 15x.
Minus 15x. And something interesting happens with the inner, that's the 3 times the 5x. What do we get on that one?
Plus 15x.
Plus 15x. And the interesting part will happen on the next line. And our last, 3 times negative 3, that's going to give us a minus 9. So let me ask you all this. What do you think I mean is interesting? We got the 25x squared here. What do you think I mean is interesting that happens with the combining of these two terms? What do they do?
They cancel out.
They cancel out. They're opposites of each other, a minus 15x and a plus 15x. They cancel each other out perfectly, and we end up with only two terms in the answer, the 25x squared and the minus 9. This answer right here is what is known as a difference of squares. And when we get into factoring, it's going to be one of the first things that we learn how to factor, because it's a super simple formula, and it's based on this idea that when you have a difference of squares, which means this thing is just something squared, and then the second term is just something squared. In particular, if you take 5x and square that, you get 25x squared, because you have to square both pieces. And if you square 3, you would get 9. When you have a difference of squares, it turns out that you can always write it as a pair of parentheses next to each other with the things being squared, one of them plus and one of them minus. It's a really cool pattern that's very, very useful. But when you're asked to multiply them, if you do these enough and you recognize, oh, well, this is what's going to look like a difference of squares, some people will skip actually even doing the outer and the inner and just do the first and the last. But you have to be careful. If these were both pluses, that would not be the case. Or if they were both minuses, that would not be the case. It has to be one of them a plus and one of them a minus. All right, let's step it up a notch and let's go with x plus 4 times 3x squared minus 5x plus 6. This is not foiling because we have a binomial, the x plus 4, and then a trinomial, the 3x squared minus 5x plus 6. So there's no first, outer, inner, last here. What we have to do is go back to the idea of distributing. Let me see if I can. That's not what I want to do. Want a little more space. So going back to the instructions above, we said you either distribute the single term like A, you FOIL like B, C, and D, or if you have multiple terms in multiple parentheses, you distribute everything in the first to everything in the second. So everything that's in this first parentheses, the X and the 4, gets distributed to all 3 of these terms in the second. So I will actually draw the mapping, the webbing, whatever you want to call it. The X is going to go to all 3 of these. I'm going to do that in blue. So this will be X times 3X squared, which will be 3X to the 3rd. Then X times the negative 5X, which will be minus 5X squared. X gives us this X squared. Then X times 6 would be a plus 6X. But then I have to distribute the 4 to everything in the second parentheses. Think of the first parentheses as your deck of cards and the second parentheses as your players. You have to give all the cards to all the players. So you get a 4 times a 3X squared. So plus 4 times 3X squared would be 12X squared. A 4 times a negative 5X, which will make a minus 20X. And a 4 times a 6, which is a plus 24. So there are 6 multiplications we had to do here. Fun fact, you can know the number of multiplications by counting the number of terms and multiplying it by the number of terms. 2 terms, 3 terms, 2 times 3 is 6. So if I gave you a 5-term polynomial and a 6-term polynomial and asked you to multiply them, that would be 30 different terms you multiply. That's not fun. And thankfully, you'll never have to do it again. And now we just combine like terms. 3x cubed, there are no other x cubes, so leave it alone. Done with the 3x cubed. The minus 5x squared would be like the positive 12x squared. So we can combine those. Minus 5 plus 12 would be a positive 7. That's a plus 7, leave the x squared alone. So that cancels that. We have a positive 6x and a negative 20x. 6 minus 20 is negative 14, so minus 14x. That cancels that. And there's just one single constant, so you bring it down. There are no more like terms. If you combined all your like terms in the previous step, there shouldn't be like terms in the next step. And there's our answer. There is one more type of these problems that we can work on now. What if we had with x plus 7 in parentheses squared? Now here's what maybe a third of students do when they rush. I'm pulling up the red marker for wrong currently. This is wrong, 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 wrong. So maybe just follow along and don't write it down. They'll go, oh, x squared is x squared. 7 squared is 49. So there we go. They box it up, they ship it out, and then it's wrong. That is wrong. That is wrong, 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 wrong. They missed half the problem. You cannot just square the x and the 7. So what is it exactly we were supposed to do? So pulling out the blue for correct. What you are supposed to do is this. You are supposed to say, all right, anything squared means take that thing, the x plus 7, and multiply it by itself. This is a very important step, because now we can see that we would have to FOIL this bad boy. So just squaring the x and squaring the 7, not good enough. You might say, oh, Mr. Beckner, back in example D, they canceled the outer and the inner terms. But I said that's only when it's 1 plus and 1 minus. These are both pluses. There's no canceling here. In fact, they'll double up. So when we FOIL, x times x is x squared. That's the first. The outer is the x times the 7, the 2 furthest away. So plus 7x. The inner is identical, a 7 times an x. They're both positive, so another plus 7x, hence the doubling up. And the last is the 7 times the 7, so plus 49. Combine your like terms, 7x and 7x make 14x, so x squared plus 14x plus 49. Mr. Beckner, what if it was a minus instead? Wouldn't they cancel then if it's a minus? No. Once again, it's going to double up, just negatives instead of positives. Equals 2x minus 3 is 2x minus 3. And we FOIL. 2x times 2x would give us our 4x squared. 2x times negative 3 would be a negative 6x. That's the outer. That was this one and this one. But it's a coincidence that the inner, this minus 3 and this positive 2x, are going to be identical in product. So another minus 6x. Negative 3 times negative 3 is not negative 9. It's positive 9. Be careful there. Combine like terms. Oh, negative 6x and negative 6x cancel. Nope. They stack. Negative 6 minus 6, same sign. Add the numbers, keep the sign. It's a minus 12x. There we are. Look at the time we have left and thinking about how much I want to do moving forward. Might get out a few minutes early today because I don't know that I want to start the trinomial stuff without finishing it. Hold on one second. Okay. So with that being said, we've got enough material to start our journey into factoring. We'll definitely not finish factoring today. I'm not going to say we're going to finish it next time. We might finish discussing the techniques, but we're still going to bring up factoring intermittently throughout the semester in this course because we'll need lots and lots of practice. But I suggest you practice sooner than later because, again, this stuff comes up in the 161 course immediately. So, you got a few weeks before our first test, like what, maybe 3 to 4 weeks, something like that. So you're okay if you're a little behind before then, but you're going to need it by the first test. All right. So I'm going to be pulling stuff from that factoring document that's in Canvas. I just kind of copy pasted something really quick. I just didn't want to have it all up there all at once. The first formula, which I already kind of spoiled earlier, is the difference of squares formula. So the idea of factoring is the exact opposite of what we did before. Factoring is to take something in the more expanded polynomial form like our answers before and to write it like the questions. And you might say, why on earth would we ever want to do that? Oh boy, are there tons of reasons that I'm not going to get into explaining except for saying to find the solutions to equations and finding x-intercepts, which can have very, very, very big implications in the long term. So let's start out with what, in my opinion, is the easiest, is factoring binomials, specifically of the form something squared minus something squared. Now notice that it has to be a minus. Minus LHS means left-hand side. And factor squares. What we call prime, and I'll have that definition up there later. And I want to have a verbal asterisk here. You can't factor a sum of squares with real numbers. They have to be imaginary numbers. We'll talk about that later in the semester. Not that far off, but definitely later. So a squared minus b squared equals a plus b times a minus b. This right here goes in line with example D previously, but backwards. This is the answer is the a squared minus the b squared. And then this is your a plus b and your a minus b. So we're going to take example D, and we're just going to show that work backwards. We're going to show the factoring process from before. Example was 3D. Yes, 3D. We had 25 x squared minus 9. This is, if you want to show all your work, what you would do. You would say A, the first term, you're trying to think of what squared would make 25x squared. And when you have numbers and variables, just think of them independently. So what number squared makes 25? That would be 5. And then what could you have that when you square it, you get x squared? And this sounds redundant because if you add x and you square it, you get x squared. So this is what we would call our A, 5x, because if you take 5x and multiply it by 5x, you get 25x squared. The B is whatever you would multiply by itself to make a 9. Well, 3 times 3 is 9. There's no variables, so I don't need an x or a y or a z there. And then all we do is we take the formula a plus b times a minus b and we plug it in. So a plus b would be parentheses 5x plus 3. Then a minus b would be 5x minus 3. And that would be the factored form. It's like Jeopardy. We had the answer, now we want the question. And again, this has many, many uses. Often in math, whatever you have is what you don't want. So if something comes in the expanded format, you probably want it factored. Factored, you probably want it expanded. We're going to show several of these. For A, we'll go with x squared minus 36. So if you want to do all the side work, you've got to say, all right, this is 2 terms. And the one thing Mr. Beckner's taught us thus far is how to factor by using a difference of squares formula. A, trying to think of what thing, if you squared it, would make x squared. This also means just take the square root of the term. Square root of x squared is x, or if you want to think about it the other way, x times x is x squared. So that's the first thing in the formula. Then B, the second thing in the formula is what squared would make a 36. Don't think about the minus. The minus is part of the formula because you can't use real numbers and square it to make a negative. Well, it'd be 6. 6 times 6 is 36. So it's just a pair of parentheses where it goes a plus b and a minus b. If you want to put the minus first, then the plus, be my guess, nobody cares. I always do plus first. X plus 6 times x minus 6. Well, that's it. That's the answer. But 81x squared minus 121. All right, so that first term has got a number and a variable. Just think about them independently. And you get used to this one really quickly. For the x squared, you know it's going to be an x. For the 81, now you can think about what number times itself makes 81, or you can just say, what's the square root of 81? Well, it's 9. 9x. And what number squared would make 121? What's 11? 11 times 11 is 121. I would suggest that you know up to 169. So 11 squared is 121, 12 squared is 144, 13 squared is 169. After that, you just got to start showing some work. Or hope it's test 3, test 4, the final when you're allowed a calculator. So pair of parentheses. One of them's got a plus, one of them's got a minus, and then it just goes AB, AB. So 9x plus 11, 9x minus 11. That's it. What if we had x squared plus 100? Now you might start this and say, oh, well, your a is x because x times x is x squared, and your b is 10 because 10 times 10 is 100. And then you'll go x plus 10 times x minus 10, and you're wrong because of this right here. Because that is a plus, this does not fit in the formula, which is a minus. This is imperative. It must be a minus on the difference of squares to be a difference. You know why they call it a difference of squares? Because it's a minus, it's a difference, it's a subtraction. You know why they call it of squares? Because each thing's being squared. The name is very obvious. So guess what? This is what we call prime, i.e. it can't be factored. And asterisks using real numbers. I have to attach that little verbal statement in there. We don't worry about factoring using imaginary numbers in here for a long time, which is why I'm not writing down that using real numbers part. See, what if we had 4x squared minus 25y squared? Uh-oh, variables in both. What do we do? Don't sweat it. We're back to a minus, so hopefully this will work. Our first term, think about the 4 and the x squared separately. Square root of 4 is 2. Square root of x squared would be x. 2x times 2x is 4x squared. For the second term, 25 and y squared, think about the 25 independently. Square root of 25 is 5. Square root of y squared would be y. That's it. There's your a and b. So we go 2x plus 5y times 2x minus 5y. Now, I'm going to do an example in just a minute after explaining this, but when you're factoring anything, when you look at the problem, the first thing you should do, something we haven't done so far, is see if there's a greatest common factor, GCF. If there is, you need to factor that before you take anything else out because it's going to make your life way easier, and the problem could actually be impossible without doing that first. What is a GCF? This is the largest number variable factor, generally the least exponent, divide into all. Another case, if I wonder if y'all can hear my dog, he is slurping up some water right now. I'm waiting for him to stop. All right, the greatest common factor, you have numbers and variables to deal with. It's the largest number that you can divide into all terms. So if you had, say, a 5 and a 25, it would be a 5. If you had a 6 and a 9, it would be a 3. And for variables, it's the least of the exponents you see. So if you have an x cubed and an x squared, it would be x squared. It's the biggest thing you can take from all terms, but you have to be fair. You can't take something that doesn't exist. So if you wanted to take an x cubed from something that only has an x squared, you can't take it out. 5. Used to be. Let's go with 3, x to the 4th, 6, x cubed, minus 12, x squared. What this is going to feel like is the opposite of distributing. We're going to take these things away. But whatever we take has to exist. It has to be there. We can't take something from nothing. So to find the GCF, some of them have numbers, some of them have letters, some of them have both. This will have both. I'm going to look at the 3, the 6, and the 12 and think about what's the biggest number I can divide all of those by. So 3 divided by something, 6 divided by something, 12 divided by something. Well, it would be 3. I can do 12 divided by 3. I can do 6 divided by 3. I can do 3 divided by 3. Some people will accidentally take the biggest number and say it's 12. But I can't do 3 divided by 12. I can't do 6 divided by 12. For the variables, and spoilers, there will be some x's, so I'm just going to go ahead and write it. There are 4 x's here, there are 3 x's here, and there are 2 x's here. So you only want to take the most that you can take. You can't take 3 because the last one's only got 2. So we can only take out a 3x squared. Here's what we do. We write the GCF first. We write the GCF first, and then we open a parenthesis. Inside of that parentheses, we will divide all terms by the GCF. So for this first one, we're saying, all right, what is 3x to the 4th divided by 3x squared? And this goes back to the exponent rules we talked about last time. We're dividing these two things. 3 divided by 3 is 1. I'm going to write it temporarily, but I will erase it after I'm done. Then x to the 4th divided by x squared, we're going to subtract the exponents, and we get x squared. Now, again, I don't really need to write this one, so I'm not going to write it. So again, the 3's canceled. X to the 4th divided by x squared is x squared. Then we're going to divide the 6x cubed, positive 6x cubed, by the 3x squared. Well, 6 divided by 3 is 2. That's a plus 2. X cubed divided by x squared, 3 minus 2 is 1. So that's an x to the first. But once again, I'm not actually going to write that 1. I'm just showing it there for a second. So you see where it came from. 3 minus 2, the exponent's being subtracted. And then for the last, we're doing minus 12x squared divided by 3x squared. Negative 12 divided by 3 is a negative 4. X squared divided by x squared, those match, so they cancel. 2 minus 2 is 0, x to the 0 is 1. So this is the answer. If you don't trust this, you can distribute to check. 3x squared times x squared, 3x to the 4th. 3x squared times 2x, 6x cubed. 3x squared times negative 4, negative 12x squared. Checks out. We'll do one more and we're going to call it a day. We're going to factor a GCF out. Humana. 15x to the 3rd, 25x to the 2nd, plus 5x. Not everything has a GCF. None of the previous examples from example 4 had GCFs. They could have. Maybe we'll see an example where we factor a binomial that also has a GCF next time. Can't wink nudge. All right. So for 15, 25, and 5. And again, if this last 5 was a 4, there would be no numerical GCF. Only take out variables. Or if this last term didn't have an x, then I couldn't take out any x's for a GCF. But 15, 25, and 5 is the biggest number that goes in all three of those. For x cubed, x squared, and x, in order to take out any x's, I have to take the least available to be fair, which would be just an x to the first. I can't take 3 because the second and third term don't have it. I can't take 2 because the last term doesn't have it. The GCF is just a 5x. So we write that first, we open our parentheses, and we divide. 15x cubed divided by 5x, well, 15 divided by 5 is 3. X cubed divided by x would be x squared. Minus 25 divided by 5 is 5. X squared divided by x is x to the first. I'm not going to write the 1. And here's where some people will mess up. They'll say, oh, 5x, the GCF was 5x. I took it away completely, so I don't need a third term. This is wrong because I don't have anything here. This is wrong because when you divide something by itself, it doesn't make 0, it makes 1. 5x divided by 5x is a 1. And that is the biggest mistake that students will make. They forget that. So be careful with situations like that. Remember, taking out a GCF is division. Dividing anything by itself is 1. All right, so we're going to call it a day for our lesson there. If anybody has any questions, speak up now or forever hold your peace until Thursday, assuming we have class Thursday. Hopefully we have class Thursday pending crazy snowstorms. Gotta love the weather in Hampton Roads. While Math 161, I do have some pre-made videos available, and I would still try and put something up on YouTube so that we wouldn't miss a class. That's not the case for MDE 61 for this class right here. So I wouldn't put anything up on YouTube. We would just catch up the next time. Fortunately, unlike Math 161, we don't have predefined material that we absolutely have to get through. I'm just using this as a support class to teach you things to catch up. So missing a class in here isn't the end of the world. Missing a Math 161 class is. All right. If you don't have any questions, we'll go ahead and call it there. I hope this was helpful. We will practice way more with factoring next class and the class after that, and then intermittently here and there throughout the semester. But for now, have a good one. Work on that 1.2 homework from Math 161. I'm still figuring out an official homework setup for this MDE 61. So just go through that chapter 1 stuff and start working on things you think you can for now. I want to do the chapter P stuff. I highly advise everyone in here to do the chapter P assignment for Math 161. I've been thinking about making some individual assignments in here, like a P.1, P.2, P.3, to break it down to where I can say, yeah, you need to get those 70s. But for now, it's just going to be kind of open-ended. Come to class, do as much homework as you can. We'll change it as I get to. All right. So hopefully we'll see you Thursday, everybody. Take care.